Hello friends, so in this video we will read the decimal part 2. In the part 1 we have already discussed about what are decimals and simple decimals, normal addition, subtraction and the division and conversion of decimals into fractions. And in this video a special case, recurring decimal numbers we will read, and different kinds of recurring decimal numbers and their conversion into fractions and addition. That is a special attraction of this video actually. Addition of recurring decimals and subtraction of recurring decimals. So how to do that? So let us start. What are recurring decimals and how do they come from? Okay, so recurring decimal numbers. The recurring decimals, how they are being formed. Suppose a number is 1 by 3. So suppose 1 by 3 is there, I will convert it into decimals. So how to do that? 1 divided by 3. So 1 will not go, so 3 zeros are 0, 1 is the remainder. Put the decimal 0, 3 3s are 9, then 1, then again 0, 3 3s are 9, 1 0, 3 3s are 9. Like this it will continue. So the division process will not end at all, right? So I can write this is 0.333 ... like this, or why ... because the division process doesn't end. Or I can write like this 0.3 bar. The meaning is same. And in some books it is written like 0.3 ... above. But this is commonly used actually. This is rarely used. Very few people use this. So this is the way. You see what decimal, the fraction, if I convert it into decimals, this is coming like this, where the division process doesn't end. So this is here after decimal 3 is repeating, means 3 is reoccurring. So we call it recurring decimal numbers. Another number, if you do it, another number. So what we'll do here, 0.142857, this is the recurring decimal form. If you divide 1 divided by 7, you will get like this, and this 142857 it will repeat, 142857, 142857. This one is repeating, right? So and this will repeat and the division process doesn't end also. So what I will write here, 0.142857 bar, right? So these kind of numbers are called recurring decimal numbers, or we can, as these numbers are repeating periodically, so we call it periodic decimal numbers, or we call it circulating decimal numbers. Periodic decimal numbers, circulating decimal numbers, or recurring decimal numbers, right? So but recurring decimal numbers or reoccurring decimal numbers, that is common. So this is one. And another, if I'll go for, there are different kinds of recurring decimals again. Number one, there are some numbers where you can find, I am giving one example. Suppose 1 by 5. If I will convert it into decimals, then what will be the answer? And the numbers where if the denominator is in terms of 5 or in terms of 2s or 5s or 2s. So how to do that? You see, this is 1 by 5 is there. If the denominator anyway can be converted into tens or hundreds or thousands like this, then these are very easy to do into decimal forms, right? So 5 can be converted into 10 very easily by multiplying 2. If you multiply in denominator 2, then in numerator also you multiply 2. So the answer will be 2 by 10, and 2 by 10 is 0.2. 0.2. Because how many digits are there in, how many zeros are there in 10? 1 0. So if you convert this numerator, write the numerator, and 1 0 is there, single 0 is dividing, so you just come back 1 places. So answer is 0.2, right? Next, Number 2, another example. Suppose there is 1.1 by 8 is there. In 1 by 8, what I'll do? 1 and 8 is there. So can we convert 8 into tens? No, because there is no number. If you multiply 8 into that number, it will be 10. So can you convert 8 into 100? That is not possible, right? Because 100 is not divisible by 8. So can 8 be converted into thousands? Yes, it is 125. 125 and 125. So this is 125 1 ja is 125 divided by 125 8 ja is 1000. Now if you convert this, this is how many digits are there? 3 zeros are there. So write 125, go to the right extreme and come back. How many places? 3 places, because 3 zeros are there in the denominator. So 1, 2, 3 and put the decimal and you put the 0. 0.125 is the answer. Now this is one. Another, what do you observe here? In the denominator 5 is there. Here in the denominator 8 is there. 8 means 2 to the power 3, right? Or 2 into 2 into 2. Another, suppose 1 by 50 is there. 1 by 50 means, again, this is 1 by 50 means what? This is 50 into 2 and 1 into 2 I will do. This is 2 by 100 and this answer is 0.2. This is 0.2, isn't it? Okay, sorry, this double 0 is there means the decimal, you write 2, then move back 2 places, right? So 0.02 will be the answer, right? Now, this is one. What do you observe here? Here in the denominator only 5 is there. Here in the denominator 2's are there, 2 into 2. Here in the denominator 50 means what? 50 means 2 2 ja 2 into 5 into 5, right? 2 5 ja 10, 5 ja 50, right? So the denominator is in 2's and 5's. So this is one kind of fractions where you will find the denominators can be expressed in terms of 2's, in terms of 5's denominators, or in terms of 2's and 5's, both, either 2 or 5 or 2's and 5's, right? So in that case you are getting a perfect decimal number, or this decimal number is terminating. These are called terminating because the decimal process terminates at some places. So these are terminating decimal numbers. Terminating decimal numbers. Terminating decimal numbers. Because the decimal process ends here. Terminating. So these are pure, these are called purely terminating decimal numbers. If the trick is, if the denominator is only in terms of 2's or only in terms of 5 or 2's and 5's are there, no other number should be there, then this decimal expression of that number, that fraction will be terminating one, right? Then next we'll go for second part or second type of the number. Second type, that is pure recurring decimals. Pure recurring decimals. What are pure recurring decimals? Now I have given one example. 1 by 3 you got 0.333 dot. That means 3 is being repeated. Another example I have given, 1 by 7 is equal to 0.142857 bar, right? 142857 was repeating, right? 142857, 142857, like this it was repeating. So after decimal, whatever the numbers are there, whatever the digits are there, all numbers are repeating. 333333, 142857, 142857, 142857. No other digit is here which is not repeating. All the numbers repeating. The series is repeating. So these are called pure recurring decimals. And what is the type? How do you identify a pure recurring decimals? By the denominator. Just in the previous example, in case of terminating one, you check the denominator. If the denominator is in terms of 2, in terms of 5, or both 2 and 5, no other number, then 100% if you convert that fraction into decimal number, it will be terminating one. Now here, if 2 is not there, 5 is not there, other number, completely other number than 2 and 5. 2 is not there, 5 is not there, 2 and 5 both are also not there, only other number is there, then you will get a pure recurring decimals. Pure recurring decimals without conversion. Also you can say, suppose somebody will ask here, suppose a number is there 1 by 11, and you will be asked, if you convert into decimals, what kind of decimal fraction you will get, or what kind of decimal numbers you will get. Just check. 11, yes, 11 does not contain 2, 5, so it is completely other number. If the denominator is completely other number other than 2s and 5s or both, then this decimal expression will be pure recurring one, pure recurring decimal number, 100%. You can check with other numbers. Now next one, another type of recurring decimal is there, which is called mixed recurring decimals. Mixed recurring decimals. So what are mixed recurring decimals? Let us see. In mixed recurring decimals, the number is of type like this, 2954, like this. You see, in some mixed recurring decimals, what we will do, the first numbers after decimal, first few digits, maybe sometimes like this, 314, only one digit is not recurring, remaining digits means 1, 4 are repeating. So how will write this? 0.3141414 like this, dot 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 dot. So 3 is not repeating, remaining one is repeating. So you see, there is a non-repeating number and remaining are repeating number or recurring numbers, circulating numbers, periodic numbers. So these are called mixed recurring decimals. And how do you, suppose some fraction will be given and you will be asked whether it's a mixed recurring or not, or what kind of decimal expression you will get if you find the decimal, then how do you identify that? So let us do like this, 3 by 18, or it can be expressed as 1 by 6. 1 by 6. 1 by 6 means, initially what you will do, you check the denominator, it is 2 into 3. I told, if only 2 is there, only 5 is there, or 2 and 5 are there, then terminating decimals. If 2 and 5 are not at all there, completely other number is there, then pure recurring decimals. Now you see here, you see 2 is there and some other number is there. So what will be there? That means if 2 would have been there, it would be completely terminating. If 3 would have been there, it would be pure recurring. 2 and 3 are there, mixed recurring numbers you will get. So you will get a decimal value which is a mixed one. 1 by 6, if you convert into decimals, let us check it. 1 divided by 6. So 0 is 0, 1 decimal 0, then 6 1 ja 6, remaining are 4, 40, 6 6 ja 36, 4 40, 6 6 ja, it will go on like this. So the decimal expression is 0.166666 like this, or you can like 0.16 bar like this. So these are called mixed recurring decimals. So there are three types: terminating, pure recurring, and mixed recurring decimals. Pure, 2 and 5 denominator, both or 2 or 1, 2 or 5. Then in terminating, that is terminating actually. Terminating means 2, 5 or both. Then pure recurring is no 2s, no 5s at all, completely other number. And mixed recurring is 2 or 5 will be there, with that some other number will be there. And before checking if some answer is some like this here, you see 3 by 18, you cannot directly tell that it's pure recurring or it's terminating or it's mixed recurring. Just standardize this fraction, like reduce this fraction into standard form or reduced form or lowest term, whatever you say, lowest term, then you check the denominator. Without reducing the lowest term, don't check. Otherwise sometimes we may fail to check actually, because some number might be there which will be divisible by 2, some number might be there which will be divisible by 5, etc., and you will not identify. So please, before answering, do reducing the number, and bring it to lowest form and tell the answer and check the denominator. So this is what. Now I will tell you the conversion of recurring numbers into fractions. So students, now I will give some examples where I will convert recurring decimals into fractions. So we'll start with very small example, 0.3 bar. This you have already done. Fraction was been given, you have converted into recurring decimals. Now recurring decimals has been given, you have to convert into fractions. So how to do that? So there is a, suppose in class high school examinations, like class 9 examinations, those who are CBSE students, you can mark it. This is there. Convert this recurring decimals into the fractions or rational numbers, because all the recurring decimal numbers are the rational numbers, right? So if you are to convert into fractions, then if the question is of 2 marks, then how to do? And for other competitive examinations, you don't need to do the process, right? You have to write only MCQ. I mean, some options will be given, you have to choose the option. So how quickly in mind you can do that also I will tell, both the method. So initially I will tell the longer method, I mean the concept, then we will go for the shortcut method. So 0.3. So whatever is given, just take, this is the question actually, convert into rational numbers or fractions. So let 0.3 bar is equal to x, or x is equal to 0.3 bar. Let it be x you are taking. Now what I will do, it can be written as 0.333 dot 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 dot, isn't it? Now if just check after decimal how many digits are being recurring. Only one digit has been recurring or repeating. So I will multiply 10x. If 2 digits would have been there repeating, then I would have been multiply 100 into x, like that. So this is 10x. 10x into this one means 10 into 0.3333 dot 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 dot. So if 10 is being multiplied according to normal multiplication rule, the decimal digit, I mean the decimal point will move one place towards the right, and this answer will be 3.333333, like this, isn't it? So now what we will do, this is 10x. You check after decimal all the digits are repeating. Here after decimal all the digits are repeating, and same digits are there after decimal. Here also same digits are there, the decimal. So what we will do, 10x minus x is equal to, this is 3.3333 dot dot dot, and this is 0.3333 dot dot dot. So what will be there? 10x minus x is 9x is equal to, see if you go on subtracting these 3's like this, so this part will be 0 actually, right? And this is 3 point something, 0 point something, 3 minus 0 is 3. So 9x is equal to 3 implies that you don't need to find 9x, because x you have taken, the original number is x you have taken, and that x you want to convert into fractions. So 9x is equal to 3, so x is equal to how much? 3 by 9, or it will be 1 by 3, right? It is 1 by 3. Now got the answer. You just remember 1 by 3 we have expressed into 0.3 bar, isn't it? So this is the method. And another I will do, if 2 digits are there, how to do that? 2 digits recurring or 2 digits are repeating. Simple. I will take a random example, 0.35 bar. So again, let x is equal to 0.35 bar is equal to, I will write 0.353535 for easy. Now this is dot 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 you should give. Now how many digits are repeating after decimal? 2 digits are repeating. So multiply 100 into x is equal to, if you multiply 100 into x, the decimal point will move 2 places to the right. So it will be 35.353535 dot dot dot, isn't it? Now again you subtract this one. So 100x minus x, 100x is equal to 35.353535 dot dot dot, x is equal to 0.353535 dot dot dot, isn't it? So what I will do, and this right side after decimal, right, the decimal numbers, these digits are equal, so this will be cut and this will be 0, and 35 minus 0 is 35. So 100x minus x will be 99x is equal to 35, but we need x, right? because we have taken this x. So x is equal to 35 divided by 99. We got this answer. Easy. So in this way, as many digits are there recurring, that much 0 you give here in 1 and multiply, and then subtract the number and find the x. In this way you can find. You do more examples for your practice. Next, these two things I will do in a shortcut method now. Shortcut method. How quickly you can do. Suppose 0.3 bar is been given. MCQ question is there. So what you will do, you write, you forget about the decimal, forget about the recurring bar which has been given. So what is the number? 0.3. Then put a divided by mark. Divided by what? Now after decimal you see, now here above how many numbers are there recurring? One number, so 9 you will write. So it is 3 by 9, the answer will be 1 by 3. Isn't it correct? Another. That same one I will do 0.35 we have found out. Now how to do this directly? Remove decimal, remove bar, write the number, it is 0.35, but this 0 you may not write, no problem. Now divided by, after decimal you check after decimal, because when denominator you come, you don't go for the before decimal, you come to after decimal. After decimal, above how many digits bar is there? 2 digits, so 2 9s. Finish. This is the answer. Have not you got that same answer? 35 by 99? Yes. So another type of I will do. Suppose 2.353 is there and 353 bar is there like this. So how to convert? Again 2353, but here bit trick will be there. Why? Because here before decimal 0 was there, but here before decimal 2 is there. That's the difference. It will create the difference. What you will do? Remove the decimal, remove the bar, write the number 2353 written, minus what is the number before the decimal? 2, subtract 2, divided by. Now very easy. Above how many digits bar is there, or how many digits are recurring? 3 digits, 3 9s. Now your answer will be ready. 2353 minus 2 means 2351 divided by 999. Fraction done. Fraction done. Another example we will do. 23.3125 bar. Write full number 233125 minus what? This part. This part means before the bar what number is there? 23 divided by how many 9s will be there? How many digits are there with recurring? 4 digits. 1 2 3 4. So 1 2 3 4. Done. Now you subtract this. 25 minus 23 is 2. So 233102 will be there divided by 9999. Done. Done. So this is the trick. This is the trick. Another. Now I will do the conversion of mixed recurring decimals. Mixed recurring decimals. Similarly, how will do? Suppose 1.233 bar is there. So let it be x. X is equal to 1.3 bar. Now you find 10x. 10x is equal to how much? If you multiply 10, what will be there? The decimal will be moving to this one. It is 1.2333 like this, right? Then this decimal mark will go here. So 12.3333 ... will be there, isn't it? Now what I will do here, this is 10x is there. So now you just check 10x after decimal 3333 digits are there, and here after decimal 23333, because after decimal same digits are not there. Here and here same digits are not there. So I have to go further. What further? So I will multiply 100 into x. So if 100 into x, the decimal point will move to here actually, 2 places, right? So it will be 123.333333 ... isn't it? Now if I get this, again I will check. Now here after decimal digits are 333333. Here after decimal digits are 333333. But here after decimal digits are 233333. So where we have same number of digits or same digits are there repeating after decimal in 10x and in 100x. So in the previous one we are subtracting x, but here we will subtract these two. So 100x minus 10x, 100x will be 123.3333 dot 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 dot, and this is 12.333333 dot 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 dot. You can learn subtraction of decimals from here also. This part and this part can be cancelled and it will be 0, and 123, this 3 minus 2 is 1, 2 minus 1 is 1, and this is 111. So now this is 100x minus 10x will be 90x. 90x is equal to 111, that is x is equal to 111 divided by 90. So this is a mixed recurring decimal. In pure recurring decimal, you are getting denominators in nines only. Single line, double line, triple line, etc. But here in mixed recurring decimals, you are getting mixed, means 9 and also zeros are there, isn't it? So how to do in shortcut? I will do this in shortcut method. Same, in shortcut method, because 2 mark question you will do like this, but if this is 1 mark question, how to do that? See, again, forget decimal, forget bar, write the number 123 minus, there also you are doing subtraction, here also you will do the subtraction. What you will subtract? You will subtract the number which will before the bar. This is the bar, the number before the bar is this one. Forget about decimal, before the bar 12 is there, minus 12 divided by how many 9s will be there and how many zeros will be there. If a mixed recurring decimal is there, 9 and 0 both will be there. So how many 9s and how many zeros will be there? Let us check. As many numbers are there, you see, as many numbers are there above the bar or recurring, that many 9 you will put. And after decimal, please do remember, after decimal, above how many digits bar is not there? Only 1, so 1 0. Above how many digits bar is there? That many 9s. And above how many digits bar is not there? After decimal, please, after decimal, how many digits bar is not there? That many zeros will be there. So this will be the answer. 123 minus 12. Have not you got the same one there? Where we are subtracting this 111 by 90. Done. Another example I will do for you. So 22.3153 bar. So how to do that? Again, directly write 223153, then minus, this is the bar number, before that this one is there, write the full number without decimal, 2231 divided by how many 9s will be there? See the bar, above how many digits bar is there? 2 digits, 2 9s. And after decimal, how many digits are free of bars, or on how many digits the bar is not there? 2 digits, so 2 zeros. So done. And this subtraction you can do. 3 minus 1 is 2, and 5 minus 3 is 2, and this is 1 minus 2, 11 minus 2 is 9, right? And here 2 will be there, so 2 minus 2 will be 0, and this is 2. Okay, so now this will be 9900 like this, 00. Okay, so this is the process, shortcut process. So now we learnt the conversion of recurring decimals into fractions. Now I will tell you a very special addition and subtraction of the recurring numbers for you. So dear students, let me write the question of addition, question number 1. So same question I will do addition and same question I will do subtraction. Let me write, add 3.7676 bar and 1.4576 bar. Here after decimal both the digits are recurring, and here after decimal one digit is not recurring and remaining 3 digits are recurring. So let us add. So how to add? First what we will do, the first step, you see here after decimal how many digits are recurring. So there are 2 digits are recurring, so I wrote the number 2 in the rough, and here total 3 digits are recurring, so 3, and find the LCM of 2 and 3. LCM is equal to 6. So why I find this? Because now you will see how I am writing here. You see 3.76 and this is 1.4, right? 1.4. So now what I will do, 1.4 and this is 3.76. Here after decimal, one digit is not having recurring mark, and here after decimal, two digits have recurring mark. So I will leave here one digit and remaining I will put a line here, and what I will write in here, see what is the LCM I have found? 6. So here in between the line you will write 6 digit of this number and 6 digit of this number, next 6 digits. So 3.7, next digit will be 6, then 76, 76, how many digits? 1, 2, 3, 4, 5. One more you have to write, then 7 and then 6. And you see I have given another line here. Why I have given another line here? LCM is 6. So I kept 6 digit inside the line. Here also I will keep 6 digit inside the line. So 1.4 written. Next 576. 576 and 576 are repeating, and next is again you can write 57, or here for the first one 3.767, 3.76 is the recurring. So 3.76, 76, 76, 76, 76, like this it will be written. So let us not write more numbers there. Up to this I will write here. Now what I will do, I will add this. So up to this you understood. Again I am just explaining. Here after decimal 2 digits are recurring. Here after decimal 3 digits are recurring. So 2 digits and 3 digit. I found the LCM of 2 and 3, that is 6. So what is my intention? Now I will write the number. First number is 3.7676767676. I will write here. But this is important in between, and why I have put a line here? Here the number is 1.4, 4 is not recurring, then 576 is recurring, right? So 4 I kept aside. So to make it equivalent with the above fraction, I mean above decimal fraction, that is 3.7 is being lined here. Then the next digit, that means 6 is there. Then after that, here 7, 6, right? 7, 6, but the line is put between 7 and 6. Here 7, 6, 7, 6, 7, 6, 7, 6. It will continue like this. Now, here also 1.4. 1.4 is there, but 576 is recurring. So 576, 576, 576. You can write here 6 also, no problem. 76. This is 757, 576. This is 76. So now normal addition and subtraction, how did you do? Suppose I will add here first. Addition result I will write here. Now how to add? You see, this is 6 plus 6 is 12, 2 carrying 1, 7 plus 7 is 14, 14 plus 1 is 15, 5 carrying 1, 6 plus 5 is 11, 11 plus 1 is 12, so 2 carrying 1. Now 7 plus 6 is 13, 13 plus 1 is 14, 4 carrying 1, 7 plus 6 is 13, then 13 plus 1 is 14, 4 carrying 1, 7 plus 1 is 8, 8 plus 5 is 13, so 3 carrying 1, 6, 6, 12 plus 1 is 13, 3 carrying 1, then 7 plus 7 is 14 plus 1 is 15, 5 carrying 1, 6 plus 1 is 7, 7 plus 5 is 12, 2 carrying 1, 7 plus 1 is 8, 8 plus 4 is 12, 2 carrying 1, then 3 plus 1 plus 1, that is 5. So my addition is done. Now what answer I should write here? The answer should be like this. Addition answer I should write here. So when I am adding, just simple addition I did. So the digits towards the right line, this is one left line and one is right line. So digits after right line, this you will exclude, you will not write. So answer will be this one. And how to write? This point is there here. So you have given point 5.2, written, but the bar or the recurring mark will not be above 2 because this part is excluded from the recurring, because 1.4 non-recurring, so 7 will also be non-recurring part. So this left side after decimal, this part will be non-recurring, and here this part where you have written the LCM number of digits, this will be recurring. So how to write that? 2, 5, 3, 3, 4, 4, this is recurring. 2, 5, 3, 3, 4, 4, this is recurring. So answer is done and this part will be excluded. This is your answer of addition. Got it, dear students? Simple normal addition you did. After normal addition, here decimal point is there written 5 point. This 2, this is the digits before this line will not be put recurring mark, but in between this part of the digits, this one 6 digits will be recurring. So this is the final answer of addition. Addition or subtraction process will be the same. Let me write the question. So here question number 2, 324.786 bar, and this is 10.193, only 3 bar is there. So accordingly I will write like this. This is 3 digits are recurring and this is only 1 digit is recurring. 3 and 1 LCM will be 3 and 1 LCM will be 3. So what I will do, I will write the numbers here. 3, 2, 4, then decimal point is there, and here 10 is there, then decimal point is there. How to write? How many digits are of non-recurring? 2 digits are of non-recurring, right? So 1 and 9 are non-recurring. Then the remaining what I will write? So the line will be put here actually. After the non-recurring part, or the digits which are not recurring, the 2 digits are not recurring, after that I will put the line. So that line will be put for this one also. So after decimal 786 is there, but 7 and 8 2 digits will be to the left of the line and remaining 6 will be inside. And then how many digits I have to write in this line? This is the line. How many total digits? 3. LCM is 3, so 3 digits I will write. 6 already, 1 digit is written. So if I repeat this, 786 is there, then another 7, 8 and 6 will be there, but 6 will be outside. Why? Already this is covered 3 digits because the LCM is 3 again. Again here 10.19 is there, then 3, this is easy to write, 3, 3, 3, then here also 3. Okay, now what I will do, I will add the numbers. If you add 6 plus 3 is 9. You can write more digits also, but I mean that will be not written at the end. So 8 plus 3 is 11, 1 carrying 1, 7 plus 3 is 10, 10 plus 1 is 11, 1 carrying 1, then 6 plus 3 is 9 plus 1 is 10, 0 carrying 1. So 8, this is 9 plus 1 is 10 plus 8 will be 18, 8 carrying 1. This is 7 plus 2 is 9.4, this is 3, this is 3. So now this will be the answer. Addition 33.98, this will not be recurring marked. Now this will be recurring marked. 011. So 011 and this side will be not written. This is addition result. If you want to find the subtraction result also, you can find the subtraction result. So how to find the subtraction result? Let us find that. Same question, same type of writing, right? And now you will write the subtraction result. So let us subtract this. Similarly, 6 minus 3 is 3 and 8 minus 3 is how much? 5. 7 minus 3 is 4. 6 minus 3 is 3. 8 minus 9 you cannot subtract. So what you will do? You bring 1. So this will be 18. So 18 minus 9 is 9. And if from 7 1 has already taken, so this is 6 is there. 6 minus 1 is 5 point. This is 4. This is 2 minus 1 is 1 and this is 3. So answer will be 314.59 will not be recurring marked, and this is 345 will be recurring marked. This is the answer. So this is the way you will add and subtract the numbers. Okay. So now we will go to multiplication. So how is the writing? You just remember that one. first find the recurrings, then the LCM, how many digits are there in one number, how many digits are there another number, then find the LCM of that many digits will be there in between the line, and when you are adding or you are subtracting, that many digits will be under the recurring mark, or remaining will be not recurring, and the right part after the line, as you saw, right part of the digits after the line, that will not be written. Okay, fine. So now let us go for multiplication. Very easy multiplication. Some questions I will do. If the multiplication I will first do by 10 or 10 to the power 2 or 10 to the power n I am writing. Suppose you are multiplying some recurring numbers into 10, into 100, etc. So that will be easy actually. So 4.0303 bar into 10. So how to do this? This is simple multiplication. How? If you write like this, the bar means 03, 03, 03, 03, dot, like this, isn't it? So if you are multiplying by 10, I have already discussed in the decimal part that if you are multiplying, then decimal value will move forward or move to the right to the one place. If you multiply with 100, it will move to 2 places after decimals, right? So this is 40 point, the decimal place will move to here, 30303 dot, but here the answer will be 4 point. Here you see it is already 03, this is 3 is there, so 03 03 03 03 is recurring, right? 03 03 03, this is recurring, can you see that? So 40.303 you can put that. So this is the answer. If 100, then you move the decimal places twice. So it is easy multiplication. And now division. Suppose another number I will take division by the numbers which is having 10 to the power something, 10 to the power something. So 0.06, I am taking one example, divided by 1000 let. So how to do that? So again I will simply write 0.0606 dot divided by 1000. 1000 means 10 to the power 3, or here how many zeros are there? 3 zeros are there. Whenever you are multiplying, then you are moving the decimal forward, means to the right side, and when you are dividing, you will move back the decimal points, isn't it? So what will be happening here? So this decimal point will move back how many places? 3 places, because 3 zeros are there. So decimal places will move back to 3 places. So for one place 1 0 is there, okay, but another 2 places we need. So how many zeros we need to put? 0, another 0 for second place, for third place another 0, then put the decimal. For first place this 0 is there, for second place another 0 I put, for third place another 0 I put, then decimal mark. So actually this 0, when you are writing the decimal final value, this 0 to the left of the decimal is written. So 0.000, this part is over. Now from here you will write 06 06 06 06. Now this is 0 point, what is repeating here? You see, this is repeating, right? This is repeating. This 000 you have already given, this 06 06 06 06 is there, right? Dot. So 0 0 0, this is 06 bar you can write. So this will be the answer. In this way you can divide the numbers. Suppose the division by 10 multiple numbers, that means tens, hundreds, thousands is not there. If any other number is there, how to divide? Simple. That is again simple, dear students. So how to do that? Let me take one very simple example. 17.26 26 bar or 6 bar I'll take 6 bar divided by 2. How to do that? See, simple division, as you are writing 17.26, 6 bar is there, and I will put the division mark like this and divided by 2 like normal division. 2 8 ja is 16, 1 is the remainder, decimal has been given here, decimal has been given here. Here decimal giving is not so important, but here you should put the decimal because you have already crossed the decimal mark and you are dividing. In case you miss this decimal, the division will be wrong, the answer will be wrong. Okay, so now what I will do, this remainder will be 2, then 2, 6 ja is 12, then remainder will be 0, then 6 bar means what? I will write like this, dot 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 dot, isn't it? So this 6 will be coming here, this is 2, 3 ja 6, again the remainder will be 0, then this 6 will come down, then 2, 3 ja 6, again 0, and this 6 will come down, again 2, 3 ja. What does it mean? The division process will continue like this, and the quotients, next quotients will be, successive quotients will be 3, 3, 3, 3, 3, 3. So our answer will be 8.6333333 dot 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 dot. That means we can write 8.63 bar. In this way we can divide very simply, very simply. Another division I will do for confirmation. Dear students, let's see. Hope you have understood, but for confirmation and perfection I will do another example for you. So 36.343 and 43 bar divided by 7. This is point, and divided by 7 I will do. And here same process actually. This is 43 bar means 4343, like this it will continue. Okay, I'll divide now. 36 is there, that means 7 5 ja is 35, then 1 is the remainder, then this is this part is done. So now you have crossed the decimal mark, so put the decimal mark here, then 3, then 7 1 ja 7, then remainder is 6, then this 4 will be coming down, so this is 64, so 7 9 ja is 63 students, so this is 1, again this 3 will be coming down, so now it will be 7 1 ja, this is 7, then again this is the remainder will be 6, then again 4 will be coming down, then 9 ja. You see what is happening here, 1 9 1 9 1 9 will be continuing here, because first 13 is the remainder, then 6, then 13, then 6, then here also 7 9 ja if I will put, then here 7 9 is 63, 1 will be a remainder, again 3 will come down, so 13 will be the final remainder to be divided. So again this will continue. So our final answer will be, this is, if you divide 36.343 divided by 7, the final answer is 5.19 bar, because 191919 is continuing. So in this way we have read in this video what is recurring number, what is terminating decimal numbers, and the conditions of terminating decimal numbers. Then we go for mixed recurring decimal, what are mixed recurring decimals, and some conversions of recurring decimals into fractions or rational numbers you can say, isn't it? Because all recurring numbers, non-terminating recurring numbers, that can be converted into fractions, right? So they are rational numbers, of course, and we did some of the addition. That is a very special case, the new case, new fundamental for some students. So please learn that, how to add that, and some if you can do addition in the same way you can write, and you can do the subtraction, then multiplication easy and division is easy. So hope you have enjoyed this video, and further if you like this video, stay tuned with us. Thanks a lot.